everybody, get ready to do lesson chapter 6, review and summary, classwork part 1 today. In today's lesson we have 0 points of notebook taking, and then we got 54 points here on our classwork for chapter 6 summary part 1. And let's go into our first example here for 6.1 section, a review of 6.1. Use the law of sines to solve oblique triangles AAS or ASA. So here are our oblique triangles here. A is a cube here, and over here A would be an obtuse angle. So we have a situation with an acute triangle, then an obtuse triangle here. If ABC is a triangle with sides A, B, and C, then here are our law of sines. A over sine A equals B over sine B equals C over sine C. So these proportions here will be equal whether the triangle is acute or obtuse. So let's try one here on our first guided practice here. Use the law of sines to solve these triangles. If two solutions exist, find both. So for number 6 up here, we have angle A is 82 degrees 45 minutes, and then B would be 28 degrees 45 minutes, and then B would equal 40.2 degrees. Or no, wait a minute, this is a dimension here. That'd be the dimension for side B. So this is our setup here. We have our two angles, and to find C, we subtract our two angles up here from 180. And we get 68 degrees 30 minutes. And now to our setup here, to find the length of side A, we have our B sine A, B sine angle A over sine angle B, and then we do our plug-in here from our known values, and we come out to 82.91 for the length of side A. And then for side C, we go B sine C, so the length of B, which is 40.2, where are we at here? B sine A, 40.2 sine 82.75 over sine 28.75, and we come out here with this dimension for sine A. And then again for the length of side C, we do our plug-ins here, our plug-in values here, and we come out with 77.76 for the length of sine C. And then down here, students, for your independent practice, you do the same thing here. Okay, you got a angle measure, and then you got two side lengths here. So you can do side angle side. And I just go ahead, it must be Friday, I threw this in for you. And just to find the side length, or rather the angle measure of angle B, we do our plug-in here, and we have 6.375 for an angle measure here. And so knowing that, let's see, that would be with this angle measure like that, it would be a no triangle form. There'd be no solution for this triangle here because it doesn't make any sense. Okay, going into section 6.2 on our review here, use the law of cosines to solve oblique triangles side, 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 or side angle side. So to do this, there's two different ways we can use our law of cosines. One is standard form here, and to find either our length of A or our measure of angle A. Here's our setup here. A squared equals B squared plus C squared minus 2BC cosine A, as long as we know our two other sides, or if we know an angle measure. And then the alternative form of this would be we would isolate our cosine A, and that would equal B squared plus C squared minus A squared over 2BC. And then our next standard form would be now for B squared equals A squared plus C squared minus 2AC cosine B. And then the alternative form of that would be cosine B equals A squared plus C squared minus B squared over 2AC. And then now for C squared, we do the same thing here. And then to find the cosine of C, we have this situation over here. So we have standard form, alternative form, depending upon which measures we have of the triangle. So let's try one now. Use the law of cosines to solve this triangle here. And then down here, I provided this sketch here to help you visualize. Like this up here, we have side lengths here of this triangle. So we're going to use the law of cosines to solve this triangle, meaning to find our angle measures here of our triangle. And then this would be what we would, here is our law of cosine calculations here with these side lengths. We find the cosine of C. We have this quotient here, and then we use our the inverse of our cosine, which would be actually a secant of this dimension here, and we come up with 97.44 degrees for the angle measured for C, and then the angle measured for B comes out to 54.75. After we plug in our other known values here, we can find our angle measure of this triangle. And then we have our two angle measures. We subtract those from 180, and then we find angle measure A is 27.81 for over there. And then down here we can do the same thing, but I'm going to let you do this on your own, students. Use this space here to figure out those calculations. 4 points here for page 5 of your classwork. If you need more room, attach a sheet, but this is your answer. I want to see your answer here. Okay, going into 6.3 here. For section 6.3, perform basic vector operations and represent vectors graphically. So in this situation here, we're going to let u equal u1, u2, and v will equal v1, v2 be vectors, and let k be a scalar or a real number. So we have u plus v equals u1 plus v1, and then u2 plus v2. Here is our first addition, a vector addition here. And then our k here is our scalar. So if we multiply u by k, we get ku1 and ku2. And then a negative of v in this case here would be negative v1, negative v2. And so if we have a u minus v scenario here, we would have u1 minus v1, and then u2 minus v2. So this is just an example here of our different ways that we can add and subtract and multiply vectors by a scalar in this situation. So we do know that, and you did cover that. And so in this case here, in this situation here for number 35, our u here is -1, -3, and our v here is -3 and 6. So for a here, which is u plus v, in this problem set here, we have a as u plus v, b as u minus v, c would be 3 times u, and then d would be 2v plus 5u. So then sketch each resultant vector. So our first one here, 35a, is for u is -3, -1, -3, and the v is -3, 6. So a here is u plus v. So we're going to add these two together, u plus v. So -1 and -3 plus -3 and -6. So when we add these two together, we get -4. And then -3 and 6 would be 3. I mean, that would be our addition there. And then our graph of that would be here. This would be our vector here for u plus v. And then our v up here would be -3 and 6 is that. And then our u would be -1, -3, which would be down here. And then when we add them together, both these converge here at our addition point there to form, remember this like parallelogram from your lesson. Go back into your classwork lessons and your homework for that review there for that one. And then b here is u minus v. So now we're going to go u minus v here. So we're going to subtract v here from u. So for that one, we have u minus v will come up to 2, negative 9. So let's see here. It would be negative 1 minus a negative 3 would be a positive 3. So this is where we get our 2. And then we get negative 3 minus a 6 would be negative 9. So the graph of this u minus v would look like this. Here we get 2 and then negative 9. Way down here, you're going to have to move off your graph here, students. When you plot that, make sure you plot it like that. And then here is a diagram of that difference problem here. That would be what it would look like. They converge down here to the endpoint here of this vector. And then over here, I'm going to let you do these on your own, students. This is 6 points here for these two, 3u, and then 2v plus 5u. If you need more room, attach a sheet. So there's your C and D. And we're going to now go into our 6.4. Find the angle between two vectors and determine whether two vectors are orthogonal. So if theta is angle between two non-zero vectors u and v, then cosine theta equals u times v over the magnitude of u and v. Vectors u and v are orthogonal when u times v equals 0. So vectors u and v up here are orthogonal when u times v equals 0. Just as a reminder. So really coming out of your classwork and your homework, find the angle between these two vectors here, u and v. Find the angle theta between these two vectors. And then down here, your independent practice is graph the vectors and find the degree of measure of the angle between the vectors. So here's u here, and then here's v here. So up here at our guided practice, this goes into your next sheet here for your independent practice. I'm just showing you your blank sheet for that. So you do this will be on your classwork sheet. But going back into, well, I guess I'm not going to show you that. We're going to go right into 6.4 part 2. Use vectors to find work done by a force. So the work W done by a constant force F as its point of application moves along the vector PQ is given by either of the following. So 1, W work equals the projection of PQF multiplied by the force of direction here, PQ. So this would be a projection form. And then work would also equal in the dot product form here. Work would also equal F times the direction of force PQ. So these are two different forms that we can use to solve a problem here that involves work. So when we have a work problem, these are the two methods here of finding a measure for work. So in an example here, determine the work done by a crane lifting an 18,000-pound truck 48 inches. And then down here we have 500-pound motorcycle stopped on a hill at 12 degrees incline. What force is required to keep the motorcycle from rolling back down the hill? So up here 48 inches equals 4 feet. So work would be 18,000 pounds here multiplied by 4. So it would be for 48 inches here, it'd be 17,000 foot per pound is what that measure of work would be to lifting an 18,000 pound truck 48 inches. This would be the measure of work done. Here And then for number 90, I do this. Force equals 500 sine 12 degrees. So we have a sine here. We use a sine function for this incline. 500 pound times sine 12 degrees equals 104 pounds. Just to stop the motorcycle from rolling down a hill. Okay, now we go into 6.5, multiply and divide complex numbers written in trigonometric form. So we're going to let z1 equal r1 cosine theta 1 plus I sine theta 1, and z2 equal r2 cosine theta 2 plus I sine theta 2. And then here's our multiplication here. z1 multiplied by z2 equals r1 r2. And then we're going to combine these things. We're going to combine like terms in here. Cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. And then when we divide here as a quotient r1 over r2, these change to subtraction signs here in this situation. And of course z2 cannot equal 0. So let's go into a problem here involving that. Write A, write the trigonometric forms of complex numbers. B, perform the indicated operation using the trigonometric forms. And C, perform the indicated operation using the standard forms and check your result with that of part B. So, okay, there's a lot there. And we go into another page here to respond to all those questions. So for our guided practice here, this is part of your independent practice down here. For these two responses up here, A, write the trigonometric forms of the complex numbers. So doing that, we have 2 minus 2i equals 2 times radical 2 cosine 7 pi over 4 plus I sine 7 pi over 4. So that would be the trigonometric form of this expression here. And then 3 plus 3i will be 3 times radical 2 multiplied times cosine pi over 4 plus I sine pi over 4. So here's our trigonometric expression for this expression here. And then B, perform the indicated application using the trigonometric forms. So here is this up here, put in here, then we're going to multiply these two together now, and we're in trigonometric forms here. And then when we multiply these out, we get 12 times cosine 2 pi. This would be 2 pi here because it would be 8 pi over 4, which would be 2 pi plus I sine 2 pi, and then this would come out to 1 here. Cosine 2 pi would be 1, and then sine 2 pi would be 0. So it would be 12 times 1 would equal 12. So I did this one part of your independent practice. Do I do this one for you? Do I do 11C for you? Well, I do. And then when you multiply these out, 2, you multiply these through here, you get 6 plus 6 equals 12. 6, and then 6i, and then negative 6i, and then negative 2i plus multiplied by 3i would be negative 6i squared, and that would equal 6 as well. So this is how you get your 12 there. And that is your Chapter 6 review and summary classwork lesson. Here is my email for solution PowerPoints and classwork sheets, homework sheets, note-taking guides, etc. Here's my contact. Thank you.